Hi, welcome to my video on multiplicity and the degree of the binomial x minus b. Multiplicity, polynomial of x minus b raised to the n power. Notice the x minus b in this one is raised to the 1 power, so I can do that. And so the exponent or degree is 1. The multiplicity is the degree, which is 1. And the x-intercept is b, the opposite. So if the x-intercept is b, it could be positive or negative. Then because it's positive, it moves like that. It's a line. It intersects at one point and it moves on through. It's a line moving through. Negative x of x minus b, the exponent is 1. The multiplicity is 1 because the degree is 1. And the intercept would be the opposite of this. So it would be opposite of b is b. That's a negative b. And let's say it's still in the same spot, but it's going down from there. So because it's positive right here, it's moving up from this x-intercept. Because it's negative, it's moving down from this x-intercept. If you want to call that a b, b could be any number on the x-axis. Now we have x minus b squared. And again, we look at, this is exponent of 1 and a 1. So right now, this is exponent or degree of 2. The multiplicity is 2. The x-intercept is still b. So let's say b is right here, but it's because it has a multiplicity of 2 is said to be tangent. So it does this, it opens, oh, my mistake, it opens upward. I'm going to put it going downward then. So the parabola opens up from the x-intercept of b. And here we have the same thing as degree 2. Multiplicity is 2 because it's a degree. The intercept is b, so b is the intercept, but this time, because it's negative, it opens down. Like this is a parabola, tangent at b. And this has a power of 3. The exponent is 3. The multiplicity is 3. The intercept is b. So we say b again is in the same spot. Don't have b could be anywhere here. But this is a cubic. So cubic again is plus, so it's going up from here. So it comes down. It hits the intercept. You see like a sideways S, I call it. There it is. Sideways S. A loop. And we have another one. This is the same degree 3. Multiplicity is 3. X-intercept is b. And let's say it's there. And it's opening down. So it's going down from here. So as it goes down, let's go back up. As it goes back up, it goes into a sideways S. And then it goes on up. So there's the sideways S right there. And notice because the power is 3 is a triple. Notice that all of these polynomials have one x-intercept at this point. There's only one x-intercept. But the powers of the binomial tells me that if it's a power of 1, then it's going to be linear. If it's a power of 2, it's going to be a parabola. If it's a power of 3, it's going to be a sideways S going up if it's positive like that. Or if it's negative, it's going to go down on the, like this on the left side, going down. Okay, let's continue. Let's look at some samples now. Y equals x minus 2. And again, the degree of this, I could put an x minus 2 with like that, or I could put a 1 here. The degree is 1. The exponent of x is 1. The multiplicity is 1. The x-intercept, when x is 2, right here, y is 0. And the y-intercept is when x is 0, y is negative 2. So when x is 0, y is negative 2. So you can see that it has an x-intercept of 2, 0, has a y-intercept of 0, negative 2. So it's again, because it's a degree of 1, it's a linear. And it has a multiplicity of 1, which means it's going to move on through because it's a line. Now, what about if we have the y equals the negative of x plus 1 all squared? The degree is 2. The exponent is 2. The degree, if you took this polynomial and did the FOIL on it, then the leading term would be an x squared. And then it would be a negative of it, but it's just an x squared. So the degree is 2. The exponent is 2. The multiplicity is 2. And the x-intercept, when you let x equal negative 1, y becomes 0. And when you let y equal 0, when y equals 0, x comes out to be negative 1. Again, let's make y equal to 0 and work that through. So we get 0, so that becomes positive. Square root of 0 is 0. So we get an x minus 1. So again, the x-intercept is negative 1, 0, which is right there. The y-intercept is x is 0, negative 1. And at that intercept, it happens to be, because it's a square, then it bounces off. It's a parabola. And notice also right here, just to show you, y equals negative of x plus 1 times x plus 1. Notice there's 2 x plus 1s, which means you have 2 negative 1s. So there's, yes, you look here and you see x is negative 1 as an intercept, but there's 2 of them. So you can only have one x-intercept at negative 1, but because it's a square, you have, if you let, think of it this way, if you let y equals 0 and solve it like that, then you get x plus 1 equals 0. So x is negative 1 right here, and x is negative 1 right here, so you get 2 of them. So that's why the power is said, yes, we only have one x-intercept, but the power tells me that I have, if you want to let y equals 0 have 2 roots for this equation, there are 2 roots, but they're equal. Here there's only 1 root. Here there's 2 roots. And if you go on to the cubic root has 3 roots, but they're all the same. Again, let's look at this one. The degree is 3. The exponent is 3. The multiplicity is 3. And the x-intercept is when you let x equal 1, or if you let x minus 1 equal 0, x becomes 1. So when you let y equal 0, x becomes 1, or you get the opposite. And when you let x equal 0, that's a negative 1 cubed. So y equals 0 minus 1 cubed. That's negative 1 cubed, which is negative 1. So the x-intercept, x is 1. The y-intercept is negative 1. And this is a cubic, so it comes, and again, because it's positive, it's going up from here. So if it's going up from here, let's come down to, and as I hit this x-intercept, again, it's a sideways S. So there's the graph of it. And to illustrate that, again, I want to take it off from here. If you think about it, I got an x minus 1, x minus 1, x minus 1. So if you made your y equal to 0, you would have x is 1 right there, x is 1 there, so you have 3 1s. But again, it only has one x-intercept, but it could have 3 roots if you made if you made this into equation equal to 0, x equals x minus 1 all cubed equals 0, you would have 3 equal roots of 1. Now it's very important that if you have a cube, you have a sideways s. If you have a square, you have a parabola. If you have just a linear, you have a line. Again, there's only one x-intercept. And to illustrate those, let me put these equations. I have the graph here. And let me graph the first one. So that's the graph. That's similar to this one right here. Let's go back to the equation. And the graph is y equals x minus 2. So when I hit graph, the calculator will graph it for me, just like that. That's the 2, that's the negative 2, and you have a line. Okay, let's go back again, and we'll highlight. Now notice that this is a black, so this one is highlighted, these are not. So I'm doing the graph of the next equation. And the graph of the next equation, here we go. And as you can see, it's just like this. So there's the equation, the negative of x plus 1 all squared. And I just show it to you again, the negative of, just put that negative of x plus 1 squared. So there's it's a parabola that opens downward because it's negative, and it has x-intercept at negative 1 and the y-intercept at negative 1. And let's go back and look at the other equation. We highlight the third one. So this is x minus 1 cubed. Here it is here. This is x minus 1 all cubed. There's the equation. So I'll push this back up. And you will see, notice it goes, because it's positive, it opens up. And I just want to let you see the equation. It's positive, so it's opening up from the intercept of 1. And there's a sideways s coming down there, going sideways. There's the sideways s. And it comes down to the y-intercept of negative 1. So there's the sideways s. So the multiplicity is related to the degree of that binomial, x minus b. Now we have some more to look at, just a little tiny bit different. For each equation, state the x-intercept and the multiplicity. So here's the equation, y equals x minus 3 all squared and x minus 2. So the x-intercept here is negative 3. And the multiplicity is the power of 2. And this x-intercept here is 2. And the multiplicity is to the power of 1. And this equation has x-intercept of negative 4. And the power of that is a 1. So that means at negative 4 is going to move on through. And the x-intercept right here is 1, and the power is 3. So that at 1 you're going to have a sideways s. And it comes, again, the sideways s comes up into the 1. Because it's negative here. And this one, x is 0 is an x-intercept. X-intercept is 3. And the x-intercept is 4. At 0, x is 0. You only have a multiplicity of 1. There's a linear going on through at 0. Right here, it's at 3. You got a square. So it's a multiplicity of 2 is going to be tangent. And this right here is a 4. And that's a multiplicity of 2. So it's going to be tangent at 4, tangent at 3, and going on through at 1. And up here, I have 2. So that's a parabola that's tangent at negative 3 going on through at 2. This is a 1. And let's look at number 4. I got a negative. Now the zeros are in the brackets, except when it's a monomial like this. So the zeros are negative 2, negative 1, and 4. And again, it's when you let each of these binomials equal 0 and solve them. Or if you put a negative 2 here, you get a 0. put a -1 here, you get a 0. You put a 4 here, you get a 0. So once you get a 0 in one of these brackets, then the y becomes 0. Now, at -2, we have a cube, so we have a multiplicity of 3. So that means at -2, we have a sideways s. At -1, we have a square, so we have a multiplicity of 2. That means we have a parabola bouncing off at -1. And at 4, we have a 1, so that means this linear is going to move on through at 4. Number 5, we have x-intercepts at 0, x squared, x-intercepts at -1, x-intercepts at 6. And at 0, it's multiplicity of 2, because the power is 2, the exponent is 2, so it's tangent, bouncing off. At -1, it's 1, so it's going on through. It's a line going through at -1. And at 6 is a multiplicity of 3, so it's a sideways s at 6. So, just taking my time and make sure you understand, because when you understand what I'm trying to say, then everything falls into place. Now for each graph, state the x-intercepts and the multiplicity. And again, note, if you have an x-intercept, you can have a degree of 1, a 2, a 3, or a 4, etc. So let's look at this graph. The x-intercept right here is -3. The x-intercept here is 0. The x-intercept here is 3. And you say, well, you can see where it's cutting through. But notice it's cutting through here, so that's a line. So the multiplicity is 1. And right here is a parabola, is tangent bouncing off, so the multiplicity is 2. And at 3 is the intercept, and there's a line, so it's a multiplicity of 1. It's going to be a linear. And here, let's look at the intercepts. We have a -5, -1, and 4. So we have -5, -1, and we have a 4. What you see in the graph is the intercepts. You only change them when you're looking at an equation. Okay, so let's look at the multiplicity. Notice at -5 is a sideways s, so that's multiplicity of 3. And at -1 is moving on through, so it's a line, it's linear. And at 4, it's tangent, it's bouncing off the 4. It's a parabola, so it's a square, multiplicity of 2. And number 3, we have this curve. Let's pick up the y-intercepts. -4, 0, and 2. -4, 0, and 2. -4, 0, and 2. At 4, it's bouncing off. It's a parabola, so it's a multiplicity of 3. And here it's going on through, so a multiplicity of 1 is linear. And here it's bouncing off, so it's a multiplicity of 2. This is a parabola here. It's tangent. And, I forgot to put a 4 in here. And number 4, the last one, is touching here. Here we go. Our intercepts are -5, -3, -1, 2, and 6. So let's look. At -5 is tangent, it's bouncing off, so that's a square, multiplicity of 2. This is -3 is the line, so it's a multiplicity of 1. This is the line, so at -1 is a multiplicity of 1, it's a line. And at 2, you can see there's a sideways s, so the multiplicity is 3, because it's sideways s, and at 6 is a line moving on through. So the multiplicity, remember, you can have a x-intercept, but you have different degrees to it. Gives you the shape of your graph. So hopefully you understand what I'm doing and you like my video, and you can, if you're not a subscriber, you can subscribe to my channel and visit my math website, www.untitled mathfullyexplained.com to find more information about me, my videos, and the content. And that's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.